Hello fellow YouTubers and friends. I'm making this video as a response to a special request from one of my viewers. He asked me if I could possibly explain the principles behind the two-stage oscillator. Now, if you have not seen my two-stage oscillator videos, I have 3 of them, you won't have any idea what I'm talking about. So either go somewhere else or go watch the videos first and then come back here. Thank you. Now, on the two-stage oscillator, you take a pendulum, okay? You attach a weight, for example, 1 pound. Now if you take 1 pound and you raise it 4 feet, you've put in 4 foot-pounds of energy, or 48 inch-pounds. It doesn't matter. You turn that weight loose and it falls, it hits with 4 foot-pounds of energy minus friction of the air. Okay? Let's get this straight. Now with a pendulum, what you've done is you take that 1 pound and you raise it up 4 feet. You turn it loose. It comes down the same 4 feet. It exerts the same 4 foot-pounds or 48 inch-pounds of energy, pulling down on the pivot of the pendulum. However, the problem is it doesn't strike the ground. It keeps on going till it goes up 4 feet on the other side, minus the friction of the air. So all you need to do is put that little bit of energy back into it, and it comes down again at exerting the same 4 foot-pounds minus the friction right here, and it comes back up the other side, and all you do is add back into it what was taken out by the friction. I keep saying friction because we've already redesigned the pendulum. We've done away with over 98% of the friction, so we have to put very little energy. Now this 1 pound exerting 4 pounds of force here, if we allow it to move 1 inch, we are bleeding off 1 inch of 4 pounds of pull, taking it back on the two-stage oscillator and doing work with it over here. Now, when it comes down that 1 inch, then does that mean it's not going to come up that 48 inches over here? Is it going to be 47? Huh? No, it's going to be the 48. Because by allowing it to come down that 1 inch, it no longer fell 48 inches. It fell 49 inches. So now it's going to come back up to its starting point, minus friction, and you've bled the work off. Now, here's the phenomenon. I like to call it a conundrum. That pull down, you actually can take work off over here, but that pull down doesn't affect the pendulum until you reach a certain point. What we're dealing here is this mathematics is exponential. The farther we let it pull down, the more energy we bleed off, the more we have to put back exponentially over here to keep it running. So the less we let it move here, up and down, the less energy we have to put back into it. But yet we get the same force pulling on the lever on the second stage. Now, again, this lever is not moving as far because we're not letting this move as far. But, again, the lever is directly proportional. And the swing of the pendulum is exponential. What we've done here is we've made a union of 2 different mathematics, and we've come out with a really nice child. You marry a male horse to a male donkey and you get a hinny. They're worthless, they can't work, they're weak, and they're stubborn and stupid. You marry a male donkey to a female horse, you get a mule, which is a very, very useful animal. They're smart, they're intelligent, they work hard, and they will not work themselves to death like a horse. What we've done is we've married two different types of math, and what we've done is we've actually turned the potential energy of gravity, the earth, and changed its form into kinetic energy. The earth is energy. It's potential energy. Just like a battery holds electricity, is potential energy of electricity. It all depends on how you turn it loose. And with that, have a good day.